So in evaluating radical functions, it's not very different from what we've been doing with functions already in terms of plugging in. Just some things we might run into is where we plug in values and we don't get a solution out, because like I've said in the previous videos, our domain's restricted, so there are only certain values for x that we can plug into our function. Also, when we get into solving, what we need to be careful of is extraneous solutions, so we always need to check our answers. So, in terms of computation, nothing too different, just a few strategies that change a bit. Alright, so with this first one, if I want to find f of 5, so my function tells me to take a square root of 4 times the input minus 4, where our input is 5. So then I'm going to simplify down, so square root of 4 times 5 is 20, minus 4, which is the square root of 20 minus 4, which is 16, and then we use our principal square root, which is 4. So f of 5 is equal to 4. F of 0, what we'll do is take the square root of 4 times the input minus 4, where the input is 0. This would be the same thing as the square root of 4 times 0, which is 0, minus 4, and that's the square root of negative 4. And this is a case where we cannot take the square root of negative 4, so this solution does not exist. So 0 is going to be a value that's outside of the domain that we can't graph with our function. Solving. So we're going to take 2 equals that square root of 4x minus 4. And we're going to solve using our methods of solving radical equations. So I have my radical symbol isolated on one side of the equation. We're going to square both sides. So I get positive 4 equals, and then over here that radical and exponent just kind of cancel out, so we'll have 4x minus 4. I'm going to add 4 to both sides of the equation, so we'll have 8 equals 4x. Divide both sides by 4, so we get x equals 2. But before I can do that, I need to check that it works. Meaning, if I go to my function, square root of 4x minus 4, and I plug in 2, is that going to work to give me this output value of positive 2? So this is the square root of 8 minus 4, which is the square root of 4, which is equal to positive 2. So that works out, so we do have our solution. Let's go through one more example here, but with the cube root. Now with the cube root, we shouldn't run into issues with solutions that do not exist, because our domain is going to be all real numbers here. We can plug in anything to a cube root. It's just even roots that we need to be careful of. So g of negative 2, we're taking a cube root of, and then be sure to use parentheses for input squared minus 4, and our input's a negative 2. So negative 2 squared in parentheses is a positive 4. Then we have minus 4. So this is the cube root of 0, which any root of 0 is just 0. So g of negative 2 is equal to 0. Here for g of 6, we'll have cube root of 6 squared minus 4, which is the cube root of 36 minus 4, which is the cube root of 32. Now I'm going to go ahead and simplify this, mostly because we haven't simplified with a cube root. We did a lot with square roots. And you just want to pay attention to whether or not they want a simplified solution. Typically they want radicals simplified as far as possible, so if you can, simplify further. If not, then we could leave it like this. But let's go ahead and look at the prime factorization of 32. It's going to be a lot of 2's multiplying to each other. So 32 can be divided by 2. which leaves us with 16, divided by 2 leaves us with 8, divided by 2 leaves us with 4, divided by 2 leaves us with 2. And then what I probably do is just run through this. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we have that. So something I mentioned when simplifying radicals that we haven't really practiced yet is the idea that we need to group the number that matches the root that we're taking. So when it was a square root, we just needed a pair, but when it's a cube root, we need 3. So it's those 3 together, which is going to give me a value of 2 to bring out front of the radical. And then while I have a pair of 2's here, with this radical, I would need a third one, which I don't have. So with that, those 2 2's there are going to be stuck. So what this will give me is a 2 on the outside, and then cube root of 2 times 2, which is 4. Alright, last one here, solving. So 3 equals this cube root of x squared minus 4. And what we'll have here is our radical is alone on one side of the equation. We're going to raise both sides to an exponent that will eliminate that radical. And with the cube root, that means we need an exponent of 3. So I'm going to raise both sides to an exponent of 3. On the left-hand side, that'll give me 27 equals, and over here, that cube root and cube exponent cancel out, so we'd have x squared minus 4. I can use my square root property here, meaning I'm going to isolate that x squared. I'm going to add 4 to both sides. So 31 equals x squared. I'm going to take the square root of both sides, which will give me x equals, since I took the square root of both sides, I'll have plus or minus, and square root of 31. Now with this one, I'm going to check in Desmos. I'm going to check the graph. So what I am going to use though is, I'm going to get an estimate for 31 here, which is about plus or minus 5.57. So I'm just going to keep that in mind as I go to the graph. So what I want to do is look for an intersection point between this line at 3 and this cube root function. So let's see what's going on here. So cube root, I can grab from my calculator here. There's a square root. There should also be a cube root, or you can do the n root, type in the 3. So sorry, I did that fast. To get the cube root or any level root, if you open up the keyboard within Desmos and go to functions, and then it's over in miscellaneous, you'll see this n root. And then when you select that, you'll be able to edit up there. When you choose the square root, it won't let you edit in that region there, so you need to grab that n root. Okay, of x squared minus 4. I'm going to close down that keyboard so you can see our interesting looking graph here. And then I'm going to draw the line at y equals 3. And here we can see 2 intersection points, ends at the positive and negative, and now is our decimal estimate for square root of 31. So that's why we're getting 2 solutions out. It's due to the shape of this graph and that the horizontal line crosses it twice.